Okay. We are going to talk about properties of logarithms. And the first property we're going to talk about is the change of base formula. Not the right one. Does anybody remember the change of base formula? Okay, if you have log base a of x, your calculator is only log base 10. So if it's log base 10, you can punch it in. But if it's not log base 10, we need a way to evaluate it. Okay, so log base a of x is log of x over log of a. Now, as long as these have the same base. What you're really going to be concerned, oh no, you don't want that. Okay. You're going to use in your calculator log of x divided by log of a. Okay. I have this b here for base. This technically works with any base as long as those bases are consistent. But we're going to use this for our calculator, and so we're going to we want base 10. So this is what we would use. Okay. The change of base formula also works if we have, here's that what I just showed. It also works for natural logarithm. Okay. What is going on? I'm struggling here. As long as we have the same base, you can take log of what's inside divided by log of the original base. Okay. So I don't care if you use the logarithm button on your calculator or the natural logarithm button on your calculator, but you are going to have to approximate logarithms that we cannot evaluate by hand. Okay? So we are going to practice that. Are you ready?
Your calculator can do any base, do you know stuff? Like,
You probably do because there could be. Your calculator really does that?
yeah.
Really?
Yeah.
Okay. I encourage you to use that feature on your calculator. However, you will need to know this because it could come up like in a question, like what does this mean kind of thing. You know what I mean?
Yeah.
So let's evaluate log base 4 of 25. If you're putting this into your calculator and you don't have a cool calculator like Tyler, how would you put it in? Log of 25 divided by log of 4. Hold on, let me tell you how many decimal places. I'll see what the book does. That way we can be consistent here. 3 decimal places. What is it, Sean?
0.842.
Are you getting what Sean is getting?
No.
Oh.
Oh, wow.
Okay. That would be a problem. Sarah, what'd you get? 3, 2, 1?
Yeah.
Okay. Excellent. Now do we agree?
Yes.
Okay. Be careful with your parentheses. If your calculator opens up parentheses, make sure you close them before you hit the divide. Okay. How about log base 2 of 12? Do that one in your calculator. 3.585. Is that what you said? Okay. Can I handle it? Okay. Now, on Friday's quiz and on next Friday's test, these should be the problems that are like free points. Okay? Is this a hard thing to do? No. You need to remember how to do it though because these are easy points on your quiz and test. Okay? Alright. Now let's talk about the properties of logarithms. Now remember, logarithms are exponents. That's what they stand for. So let me ask you this. If we have two numbers x squared times x cubed. If we combine those, what do we do with the exponents? Okay, if we're multiplying numbers with the same base, then we get to add their exponents. So, if there is multiplication inside of our logarithm, we can break up that logarithm by addition. It works for log base A, which includes the natural logarithm. Don't feel like you have to write both of them down because they mean the same thing, but you can if you need to. Okay. Let's talk about division. If we are dividing numbers who have the same base raised to an exponent, what do we do with the exponents? We subtract them. So if there's division inside of our logarithm, we can break it up by subtracting our logarithms. Our last property is power to the power property. So what happens if we take a number raised to an exponent and we take that to an exponent? We multiply our powers. So if we have something raised to a power inside of our logarithm, we can multiply it out in front. Okay, so this u to the n comes out and is multiplied in front of the logarithm. We're going to do a couple examples. I feel like a lot of you are feeling like you remember this from last year a little bit. All right, so we'll do a couple examples and then that's it. That's all I have. So here we go. Log base 4 of 5x cubed y. Now I know that some of you are going to be able to look at this and write out the expanded version right away. I'm going to break this up into two steps. First of all, 5x cubed and y are all being multiplied. So we can break this up into three different logarithms. Log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Is this completely expanded? No, we have this x cubed inside the logarithm. So that needs to be rewritten as 3 log base 4 of x. And done. Okay? I know that some of you can go from here to here without needing this step in between, and that is fine. If you need the step in between, that is also fine. Okay? But on these, I wouldn't necessarily need to see all of your work. All right, let's look at this one. Square root. Anytime you see a radical, it needs to be rewritten. Instead of square root, what would we need to write instead? The 1/2 power. So I would want you to think of this as the natural log of 3x minus 5 to the 1/2 power over 7. Okay? So first of all, those two are being divided, correct? So we need to separate into two logarithms with what in between? Subtraction. So we have the natural log of 3x minus 5 to the 1/2 minus the natural log of 7. We have this power, though, inside of our logarithm, so that will need to be multiplied out in front. Why did I stop? What? Okay, we cannot separate this. There is subtraction inside. We can't separate out subtraction. We can only separate multiplication and division. So the 3x minus 5 has to stay like it is. All right, 2 more examples. Now we're going to go the other way. We're going to condense. So I have multiple logarithms that I want to squish into just one. This is going to be a technique very useful when we solve equations. Okay, so this is important. So first of all, what does this 2 mean right here? Okay, so this means the natural log of x plus 2 squared minus the natural log of x. Okay, now that subtraction means we can squish these two together where what is inside of our logarithm? Division. So it's the natural log of x plus 2 squared divided by x. It is only one logarithm with division inside. Okay, I see a lot of people trying to write a logarithm divided by a logarithm. That's not what is happening here. We have division inside of one logarithm. Is everyone okay there? Okay, last example. Okay. Please be careful with your order of operations. Okay, pay attention to parentheses, especially if there's, in this example, we only have 2 logarithms with addition in between. Sometimes you're going to get 3 logarithms where a couple might be separated by addition, the other subtraction. Okay, so just be careful with your order of operations. Now, let's work with inside the parentheses first. Okay, that would be order of operations. How do I rewrite what's inside our parentheses? Log base 2 of x times x plus 1. Right? Okay, now we have that 1/3 power. Or, I guess, I just gave it away. We have that 1/3 multiplied out in front, which means we take it inside and it becomes the power, correct? So you can write it as a power, or you know that this power means the cube root, right? And so we can write this as the cube root of x times x plus 1.
You don't have to multiply like the x into the x plus 1.
I would be okay either way. You can do the multiplication or you can leave it like that.
Okay.
Okay. When we get to solving, you would want to multiply that out, but right now it is not a big deal.
Okay.
Okay. And I'm trying to think, when you look at your homework, They're gonna leave it not multiply.
Okay.
Okay? So for your homework, don't worry about multiplying with that. Okay. All right, let's get started. Our quiz on Friday is going to be over Monday, Tuesday, Wednesday's material. So logarithms or exponentials, logarithms, expanding, condensing. All right. Tomorrow we will work in class on some review problems, and you'll get a problem set tomorrow.